Thanks for coming, everyone. I'm here to speak about small language models. Before, just brief introduction, my name's Roberto. I'm originally from Venezuela, and I am currently the AI and data engineering lead for the Magnum ice cream company, which is currently spinning out of Unilever as a separate company. I'm going to talk about three things today. The first is, what is a small language model, and why is this important? The second thing is we're going to go through some leading papers on and put those together into a framework that you can use to apply them at work or as a hobbyist. And finally, we're going to go a bit more technical into the free routes you have to deploy these models and the different trade-offs that you have through each of these alternatives. So let's start with what is a small language model. First thing is, when you go on HuggingFace and you click on the models part of the website, you'll see this new slider they added. It's really nice. It's basically to filter out depending on the weight class of the model. So models have parameters, right? And a small language model is considered when it's at or below 12 billion. It's not really a hard border, can be a bit more, depends on who you ask. But for the sake of this talk, let's say it's a model that's 12 billion parameters or less. Now, you might ask, that sounds significantly smaller than the state-of-the-art models that are actually over 500 billion parameters. How can they stand a chance? And it's not really a direct competition. This is about power versus focus. A large language model is a bit like a floodlight. It was trained by gobbling up what seems to be the entire internet. It knows about quantum physics, but it also knows about Bravo TV shows. Whereas a small language model, usually they are created with curated, smaller and more domain-specific training data. So think of it as using a pocket calculator for a task or having a supercomputer available to you. And why is this important? Because you might ask, well, I have Gemini 2.5 Pro on my phone, or I have GPT-5. I can just go always to the most powerful model and use it even for the most trivial task. Now, there's two main dimensions. One is this study by MIT Technology Review found that they basically grabbed the Llama free series, and they grabbed the 8 billion parameter variant, and they grabbed the largest sibling of the series, that's 400 billion parameters. They found that for the exact same task, it had 58 times more electricity usage. And this is something that, as models get bigger and as they have different functionalities, so one of them is reasoning. So you see a lot of models these days have thinking capabilities. If you have the exact same model and you turn thinking on or off, you can consume 43 times more electricity through that inference. And compound that together. Now then look at a large model with thinking versus a small model without thinking. You're looking at thousands of times less electricity. And if the environment doesn't pull your heartstrings, it's also a matter of money. So if you have, and again, I'm very careful putting costs next to each other, so that's why I just put the GPT and its mini cousin next to it. But just within this same family, you can have 5 times less just by using the mini endpoint of the same provider. And you can, of course, go further if you go, it's a wide ecosystem. There's many competitors to a specific model. Now, let's go into how do we put this together. Let's make a framework together on how can I actually use these smaller models at work. Because if I go on HuggingFace, I'm just going to see tens of thousands of models. I actually get dizzy. And there's always a new model dropped every week. So let's start with this OpenAI paper, basically a practical guide to building agents. The first thing they say you should do, which is actually, ironically, the last thing I've seen some people do, is actually start with the baseline. So what does good performance look like? If you have a specific task, what does the good outcome look like? What is good enough? You start with that baseline, and then you iterate on it. So as soon as you have good enough, you find the smallest model possible that reaches that threshold of performance. The second paper I wanted to talk about is by NVIDIA, and they actually name it small language models are the future of agentic AI. They focus not so much on a single agent or a single task. They focus on AI systems. AI systems usually have tools or smaller LLMs that are focused on a specific task. And that actually sounds a lot like a small language model. So what they advocate for is, for multi-agent systems, you should have a modular design where a component is specialized in a certain thing. And then only use the larger siblings when you need complex reasoning or some sort of, well, usually the orchestrator will be a larger model. Now, let's put this together. Then you have a threshold of performance and diminishing returns after you reach the baseline, because let's face it, how much better can a summary be if it's done by a small model or the ultra version of a state-of-the-art model? So it's all about reaching that performance before you reach that diminishing return. And for larger systems, you map out the modular system that you want to achieve, what tasks and what tools does each agent or sub-agent have at their disposal, and you start with a baseline. So literally, this can be like start every subtask with Gemini Flash, see if that's good enough, if it's good, or GPT Mini, and see if that's good enough. If it's good enough, then you have your threshold. And then over time, what you'll do is you'll find that you can throw challenger models at them. And you can end up with a heterogeneous system where maybe for this compiler, Gemma, which is a smaller sibling made also by Google, is really good. But for coding, you actually used a coder model that's specifically trained for coding and is way smaller than the generalized one. And then for the orchestrator, maybe you keep the large one, or you keep a larger one with reasoning on. Now that we have that sort of framework, what can we actually do to achieve it? So if I have, imagine, a model I want to test out, I can do 3 different things. So I could use the pay-as-you-go option. It's the easiest one. I could use a managed cloud platform. If you're at work, it's very important that your data stays secure. So that's what this one's thinking of. And the local deployment one, if you're a hobbyist, if you have an edge compute device, or if you have, frankly, very, very sensitive data that you don't even want to trust to your hyperscaler, then you go this route. Before we go in there, there is a very important concept that's also about making models smaller. It's called quantization. So before going into this, I'm going to go into quantization. Quantization, if you've ever had an Excel file with a ton of columns with numbers, if you save that file, the original file, it'll have a certain size. I invite you then to round up some of those columns on the file and save it again. So remove decimals. You'll see the file get smaller. It's the same principle with language models. These language models have weights. Those weights have decimals. And the quantization engine will partially or totally round up to a certain point. When you go on HuggingFace, you find the source model that's published. So in this case, it's a Qwen model. And you can actually see in the model tree, they have quantizations available for it. But this can get, again, messy. Just like the plethora of models, there's also a plethora of quant providers. And this is just one provider, how many quantizations they're giving me. Also can get hard to navigate. And what is even the difference between 16 and 4 and 1? And why shouldn't I just use the 2-bit one? So as I mentioned, it's a bit like keeping more or less details. On the left, you have the full-size model. This is an image that you took like with your latest phone. It has the trees. You can zoom in and see like the little squirrels on the top of the tree. And that has a certain size. if you put that through a quantization engine, you can get it to be 2 times smaller and actually have a negligible performance drop. So you're talking size and inference that is a lot less carbon intensive, and it's just faster. You can keep going as well. So you can do a Q8, which is 4 times smaller, and you have actually not too much of a performance drop compared to the original model. And this is often a sweet spot for inference endpoints. So when you actually go to a commercial inference provider, they're sometimes giving you a quantized model. You can keep going, and that's going to get a bit more blurry, but still workable. And you reach Q4, which is 8 times smaller than the original model. And this is often used for running on edge devices or locally. So it will do the job, but it's of course not. It won't be as good as the original one. And a fun fact: sometimes inside the models, like think of it a bit as a tree. Sometimes inside the model, some parts are natively quantized. So the OpenAI or open source model that they just released has some parts of their network are natively Q4 quantized. So it's something that's widely used. But if you go below Q4, this image starts to get blurrier and blurrier, and you start to see severe performance drops or calamitous performance drops. So my advice is just don't go below Q4. Anything that's below a Q4 quantization is not worth exploring. The other way to make a model smaller is to use distillation. Distillation is you have a teacher model that's very big, and you can actually expose the teacher to a student model. And then that student model will imitate more and more the behavior of the teacher. You can see this also on HuggingFace. When you see, for example, this DeepSeek model, the original model has 600 billion parameters, and the DeepSeek team created a distillation using an open source model, Qwen, 32 billion, where they had DeepSeek train a 32 billion model. So that was their way of giving a small version of the same model. Okay, sorry for the parenthesis in theory, but it was important for this and actually that and that as well. So the 3 routes: local deployment, managed cloud platform, and API access. So for local deployment, the 2 biggest takeaways I'd like is, if you're interested in this route, join the Reddit community, Local Llama. It has so many good, very talented, very helpful people that do this every day, and they've done some really impressive stuff. So my main takeaway, if you want to go down this route, go on Reddit, Local Llama, really good. The other main takeaway is, of course, if you're running stuff on a computer, RAM is the king. So anything you load will run on the RAM, and there is a difference between graphics RAM and GPU and CPU, unless you're working on an Apple device that has unified memory. If you want to run stuff locally, there's also a special format you need to use. This format is called GGUF. And it's when a quantization provider publishes a quant, they usually do it in this format. Again, there's a lot of quantization providers. I just recommend, usually Unsloth has very good quantizations. And there's also Bartowski, I like them also a lot. But Unsloth, if you want to start using a quantization for someone, that's usually a very reputable name. Then this GGUF is used by something called Llama CPP. Again, Llama CPP is something that's not really like usable, or it is usable, but it's more technical. But on top of Llama CPP, there's some really good projects. One of them is Ollama, and there you have LM Studio. And you can use these, that in turn use this to interact with the GGUF. If you do this, and you are on Windows, you actually need to manually configure on Windows and tell it that Olama needs to use your VRAM. Otherwise, you could have the best computer in the world, and if you don't tell Olama to actually use the VRAM, it won't. It will go to the CPU, or you'll leave it to chance. So unless you're on a MacBook, then you don't have to do anything because they have what's called unified memory now. How do you do it? How do you actually then use a model? Once you have Olama installed, Olama has a very pre-compatible catalog that you can go on their website, and it's just a terminal run to actually download and set up the model to run locally. But the thing is, remember the quantization talk we had just now? They're not really telling you in the naming convention. They're just saying this is Qwen3 8 billion parameters. But if you go into, then you see it's a Q4 quantization. It's not really the full model. If you want to get maybe a bit more performance, you have the option of doing, you'll get the slides, I think they'll post the PDF, so don't worry about if going too fast, you can review it with time later. But you can actually then, in Olama, create a model file where you do system prompts, and you can just get your own GGUF from HuggingFace. So you don't have to, you're not tied to whatever Olama puts on their default catalog. How do I actually use this after? Well, one way to use this is you could put this on GitHub Copilot. So GitHub Copilot supports Olama as a provider. And after you create the model, you can just select it. And then you run on your chat. It'll run on your local model. There's also something called continue.dev, which is pretty much the same experience as GitHub Copilot if you want an alternative. Again, it'll be on the slides. You can access the event will provide them. Next, we have the managed cloud platform, because this is very nice, but I, for example, don't have a latest state-of-the-art MacBook Pro, or I don't have a NVIDIA rig at home. So this can be limited. It can have limitations if you don't have the hardware. The managed cloud platform becomes a bit more another option, especially if you're working even, like if you're doing this for work. Now, to run something on a managed cloud platform is basically you are grabbing the model, you are uploading it into the cloud, and you're basically using Google or Amazon or Azure to run that model on their computers. And the good thing about this, if you are doing this for work, is that the data will stay in your tenant. The strategy we follow in Magnum is the following. So, of course, we also have, I'm going to go through one approach with Databricks. There's also a, you could argue, easier way with Azure AI Foundry. But I wanted to stay a bit platform agnostic, since not everyone here is on Azure. So if you want to do a custom serverless endpoint deployment on Databricks, you can use the HuggingFace CLI to download the model into what's called a Unity catalog volume. Then you use the transformers library to run, to create a wrapper. You declare it into Unity catalog, and then you create a serverless model endpoint that you can hit as an API. Again, these things will all be published by the event, so you can go through them in your own time later. But just a quick overview. So as I mentioned, we download this. This is just a simple script. You install the package. There are a few settings that you need to change from the default. Otherwise, it won't be compatible with Unity catalog volumes. Then you make the wrapper. This looks a bit intimidating, but honestly, if you give the model documentation, I use this with Gemini. So I gave the model documentation from HuggingFace to Gemini, and I said, I'm planning to deploy this into Unity catalog for a serverless, and then it helped me make the wrapper with transformers, and of course, mention that you want to use transformers. And then finally, in Databricks, you can declare the model. One thing to look out for, this was actually 80% of my time when I was setting this up was getting the dependencies right. So that was a and of course, mention the code of the wrapper that you made and put the dependencies, right? And at the end, you'll have in your Unity catalog the actual model that you downloaded, ready to use. And then last step I did through the UI. You can, again, grab that thing and deploy it in the cloud. And Databricks has these GPUs available for that. And I have a table here that you can select, depending on the size of the model, which GPU to put the serverless endpoint on. And after that's done, disclaimer, this actually takes a long time. I think this is an 8 billion parameter model, and it took a good 40 minutes to create the actual serverless endpoint. But then you can just hit it finally with an API. So you can use it with Python. You can use it with Databricks SQL. So it's actually quite good. But again, this is usually if you're in a company and you have it's not exactly always cheaper than the token, than the paper token option, which is the final option. So the final option is Cloud API access. This is when you go on any major provider or HuggingFace, and you just use an API that they host, and you're paying by the token. So you have a bit less control in this way. Let me actually stay in this one. So you have less control. One thing that's actually happening a lot is as models evolve and they are published, the rate at which endpoints are deprecated is something that is, I've never seen something like that where someone puts an endpoint in production and you could expect that 1 year later it's no longer available. So if you use cloud APIs, it's often the case that as a new model is launched, they sometimes deprecate all the API endpoints, and you have to be careful to be able to run that and to rewire to whatever new endpoint exists. One of the ways I use this is to play around with a model. I use the HuggingFace, either the playground, where you can have the simple interface with system prompt, and you select your model, and you have temperature, like you have your nice parameters here. Or you can also have, you can use this with GitHub Copilot. You put your token on Copilot and use it. However, one thing to look out for is, of course, the privacy policy. You need to be careful what you put in there, because just be sure before you put any company secrets in there that you read it and you're comfortable with it, because it could be used by humans. One alternative that I quite like is the new coding agents available on CLIs. One of them is the Gemini CLI. There's equivalents for this. There's Qwen3, there's Claude Code. And this is basically, you're on your VS Code, you get Gemini. If you're at work and you have Google Cloud, you can actually authenticate with your work ID, and that will have a completely different privacy. What you put on there will have a different treatment than if you would log in with your personal account. But the important thing is that these two have free tiers on state-of-the-art models. So if I were to use Gemini 2.5 Pro on my own, just directly through the Vertex using an API key, I spent one day in a personal project, I spent like 500 euros in a day by mistake, because these costs grow exponentially. As the context goes up, the token count goes up, and what a lot of people don't realize is that every time you click send, you're being charged for the total token count, not just the message, the last message that you send. So it's always good when you're doing the API route that you leverage things like Gemini CLI that has a free tier, and that just be very careful, because I've seen it many times that people lose track of the paper token mechanism and end up with a big bill. And this is a way to mitigate it. The free tier of Gemini, if you run out of free requests, it actually downgrades you to the Flash version, and that sort of protects you. I really love this. It's sort of my favorite tool. It's quite easy to install. You have Node.js, and it's npm install, and then you just run it. It's quite nice. And of course, there's other alternatives. This was open source, so Qwen created their fork of it. So where you use a Qwen thing, again, the data goes to Qwen, so be careful with that. And then Cloud Code similar. Finally, that was a lot, I know, but I'm just trying to now summarize a bit what we've done. So the main thing is start with performance and then iterate. So you have your baseline model, and then you post challenger models. And you want to dethrone the challenger, usually with a smaller or more specialized model. Always look at the license. To give a very concrete example, there was Llama 4 that was launched. Some of the licenses actually did not allow for use by companies based in Europe. So please just make sure when you pick a model out of from HuggingFace that you're familiar with the terms and conditions. And another one, if you see an instruct version, if you see a model and the same model instruct, use the instruct version because it's configured to interact with users. And of course, use there are some leading players. These are my recommendations when I want to use a small model, like the HuggingFace team's doing some great stuff. Qwen, I mean, they are really on fire lately. But I also really like the Gemma models by Google, Mistral, and Phi, which is by Microsoft. So these are the models the providers I usually go to when I want to use a smaller thing. So that leads me to the takeaways. Again, going back to the start, what does good look like? And then iterate on the smallest model. So start with reaching that threshold and then post challenger models to overthrow the champion, let's say, and that will lead to a better outcome. That you're always trying to get the smallest model possible for the same performance. Leverage like some of the best players out there. Usually the size of the model is indicative of performance, but usually these teams have models that punch above their weight. For local deployment, Olama and LA Studio are really great. This route provides offline performance, edge cases, maximum privacy, but of course you need investment in the hardware and maintenance, of course. Cloud is a bit more technical to get the endpoints running, but the native cloud offerings to achieve this are getting better and better. And finally, well, this is available like water, but just be careful. Look out for yourself in privacy. Look out for yourself with token pricing, especially for long context. In general, I never really recommend for long context conversations because even the model will perform worse. And finally, if you're going to do this, try to leverage something like Gemini CLI or Cloud Code. Sometimes they have very generous free tiers. That's it from my side. Thank you. I'm not sure if we have time for questions, but thank you.